All right, let's go. Number 10. Ton 618. Imagine something out there that doesn't need to roar, doesn't need to streak across space like a comet, and doesn't need to explode like a dying star. Yet it could still make entire star systems vanish like dust getting sucked into the universe's vacuum cleaner. That's Ton 6181 of the largest supermassive black holes ever discovered. It weighs in at about 66 billion times the mass of the Sun. Yeah, 66 billion. That sounds less like astronomy and more like somebody accidentally leaned on the zero key and hit save. Ton 618 was discovered because of the blazing quasar around it, the intense light produced when matter gets superheated right before it disappears for good. That light traveled for more than 10 billion years before reaching Earth, which means this monster was already out there when the universe was still young, when the first galaxies were still taking shape, and everything in space was even messier than rush hour on an LA freeway. And we still don't really know how something like this grows that big that fast. The biggest stars we know can only leave behind black holes a few dozen times the Sun's mass. Ton 618 skipped that whole level and went straight to final boss mode. It doesn't chase anything. It doesn't have to. It just sits there in the dark and gravity handles the rest. Its event horizon, the boundary where not even light can turn back, is so huge it almost stops making sense. Drop Ton 618 into the center of our solar system, and it would swallow those familiar orbits like they were just rough pencil sketches. If the Milky Way drifted too close, our galaxy would probably disappear like a speck of dust. You'll never see Ton 618 with your naked eye. But once you know it's out there, the night sky doesn't feel quite as peaceful anymore. It becomes something deeper, darker, and far less innocent because somewhere in that vast silence, a monster is still feeding on light. Number 9. Porphyrion, the largest jet system ever seen. The night sky looks calm. That might be the universe's biggest scam. Somewhere billions of light years away, a galaxy has fired out two streams of matter so enormous that if you drew them on a map of the cosmos, they wouldn't look like jets anymore. They'd look like two slashes cut straight across the dark. Its name is Porphyrion. Porphyrion is a giant radio galaxy, and its jets stretch for about 23 million light years. The Milky Way is roughly 100,000 light years across. Porphyrion reaches out hundreds of times farther. Next to it, our galaxy stops looking like a grand empire of stars and starts looking more like a tiny island floating in a black ocean. At the center of Porphyrion is a supermassive black hole. In the region around it, matter gets accelerated to nearly the speed of light and blasted outward into space. And those jets don't travel a few thousand light years and quit. They keep going, punching through intergalactic space, carrying energy, magnetic fields, and hot plasma for tens of millions of light years, like somebody gave a black hole permission to doodle across the universe and it got a little too enthusiastic. What makes Porphyrion even stranger is that it doesn't live in some especially dramatic corner of space, and it doesn't exactly give off, "Hello, I'm the final boss" energy. It just sat there almost anonymous until astronomers realized its radio lobes were so vast they reached scales comparable to the cosmic web itself, the enormous network of matter-linking galaxies across the universe. You won't see Porphyrion with the naked eye. But once you know there are black holes out there that don't just swallow matter, they can also launch structures tens of millions of light years long, the night sky stops pretending to be harmless. It becomes something colder, wider, and far harder to trust, a place where even silence can stretch farther than the human mind was ever built to hold. Number 8. Hercules Corona Borealis Great Wall. If someone told you there's a wall out there so huge that even light would need nearly 10 billion years to cross it, it would sound like a YouTube title trying a little too hard. But the universe has a real talent for being outrageous in ways that are annoyingly believable. This is the Hercules Corona Borealis Great Wall, a structure inferred from an unusual clustering of distant gamma-ray bursts. If it really is a single physical structure, it spans roughly 10 billion light years. This is not a wall in the brick and concrete sense. It's a region on the cosmic map where signals from dying stars show up more often than they should. Astronomers didn't spot it the way you spot a bright galaxy glowing in the dark. They found it through brief flashes of gamma rays, then pieced those flashes together into something much larger. And what emerged looked less like a neat structure sitting quietly in space and more like a scar stretched across the universe. Based on what we think we know about the cosmos on the largest scales, matter is supposed to be distributed fairly evenly. This thing apparently did not get the memo. It stretches, connects, and spreads across space on a scale so absurd that even our best-looking models start to seem a little less confident. Some scientists argue it may be nothing more than a statistical fluke or the result of incomplete data. In other words, even the universe knows how to make people go back and check their homework. Whether it turns out to be a genuine structure or one of the biggest fake-outs ever pulled by cosmic data, the effect is the same. The night sky stops feeling like a flat black curtain dotted with a few harmless lights. It starts to feel deeper, colder, and wide enough to make human life seem like the briefest flicker of stardust. Number 7. Giant arc, the colossal curve in the sky. At first, the giant arc didn't show up as one of those wow, look at that discoveries. It appeared in a much more annoying way as a detail that simply refused to disappear from the data. Astronomers were mapping extremely distant galaxies when they noticed something that looked like a massive curve stretching about 3.3 billion light-years across and sitting roughly 9.2 billion light-years away. At that scale, calling it a large structure feels a little understated, like calling the Pacific Ocean a puddle. The problem is, the universe isn't really supposed to behave like this. On the largest scales, matter is expected to be distributed more or less evenly, not gathered into shapes that are this long, this continuous, and this organized. The giant arc does almost the exact opposite. It bends across deep space as if someone took an invisible marker, drew a single line across billions of light-years, and then walked away, leaving astronomers staring at the map as they'd just found an extra question on the test that definitely wasn't in the textbook. This is not some giant glowing red arc hanging in the sky. You're not going to step outside, look up, and see a cosmic curve lit up like a sci-fi movie poster. The giant arc only revealed itself when the data became deep enough, when scattered points were finally connected, and when humans were patient enough to accept that sometimes the universe has absolutely no interest in making itself neat and easy to understand. That's why the giant arc doesn't overwhelm you in a loud way. It does something stranger. It makes familiar numbers stop working. 3 billion light-years stops feeling like a distance and starts feeling like a reminder that, on the scale of the cosmos, even our idea of too big is still way too small. Number 6. Phoenix Cluster, the cosmic furnace. The Phoenix Cluster doesn't feel like a graveyard of galaxies. It feels more like a gigantic furnace that never shuts off. Located about 5.7 billion light-years from Earth, this enormous galaxy cluster contains hundreds, possibly close to 1,000 galaxies, all swimming in gas so hot and so bright in X-rays that it ranks among the most luminous clusters ever observed. At its center sits a giant galaxy, and at the center of that galaxy is a supermassive black hole pumping energy into the space around it. Normally, black holes like that act a little like a thermostat. They heat the gas, keep it from cooling too fast, and stop star formation from getting too out of control. The Phoenix Cluster basically looked at that script and said, no thanks. In its core, gas is still cooling and forming stars at a rate of about 500 solar masses a year, while the Milky Way produces only about 1 solar mass of new stars per year. If the Milky Way is a neighborhood diner, Phoenix is a restaurant kitchen on opening night, where nobody ever turns off the stove. Observations from Chandra also revealed huge cavities in the hot gas near the center of the cluster, likely carved out by jets of energy blasting from the region around the black hole. Around those cavities are long streams of gas and dust stretching for hundreds of thousands of light-years, churned up and still cooling at the same time. In 2025, data from the James Webb Space Telescope also revealed gas at intermediate temperatures, helping connect the full picture from the superheated gas to the colder gas actively forming stars. So the Phoenix Cluster doesn't look like a place sitting quietly in the dark. It looks more like a city of fire that's building and collapsing at the same time, creating new stars, while a giant black hole tears holes through the very gas feeding them. On that scale, creation and destruction don't take turns. They happen all at once, like the universe dumped everything into a pressure cooker and forgot to read the instructions. Number 5. El Gordo, the giant, that showed up too early. El Gordo feels like a spoiler the universe dropped way too soon. We're looking back to a time when the universe was only about half its current age, roughly 6.2 billion years after the Big Bang, and somehow there was already a galaxy cluster so massive that astronomers nicknamed it the Fat One. Its official name is ACT-CLJ0102-4915, but let's be honest, nobody was planning to say that in a trailer voice. Hubble described it as the largest galaxy cluster ever found at such an early stage, with a mass reaching around 3 quadrillion times the mass of the Sun. While the universe was still basically setting up the furniture, El Gordo had already walked in like a skyscraper. It's also the aftermath of a collision between two galaxy clusters smashing into each other at millions of miles per hour. Data from Chandra and ESO showed that the hot X-ray emitting gas was slowed down and separated from the dark matter during the crash, which is why El Gordo is often compared to the bullet cluster, just much farther away and much earlier in cosmic history. Chandra also described it as the hottest, most massive, and most X-ray luminous cluster at its distance or beyond. Later, Webb even used El Gordo as a giant gravitational lens, bending and magnifying the light from background galaxies behind it. El Gordo doesn't hit hard just because of its size. It hits because of when it existed. Finding something like this in a young universe is like opening a history book and discovering the first chapter already has an empire in it. On that scale, too early stops sounding like a small detail. It becomes a reminder that the universe does not grow in the slow, orderly, polite way humans like to imagine. Number 4. Alcyoneus, the galaxy with invisible wings. Alcyoneus didn't enter astronomy like a king wearing a crown. It showed up more like a very polite plot twist. Look at the host galaxy itself, and nothing seems especially wild. A fairly ordinary elliptical galaxy, not the kind of blazing quasar that looks like it wants the entire universe to follow it on social media. But when astronomers stitched together radio data from LOFAR, the part that actually mattered came into view: two enormous plasma lobes stretching a combined 5 megaparsecs or nearly 16 million light-years. When it was announced in 2022, it made it the largest known structure ever produced by a single galaxy. Alcyoneus isn't huge because it has more stars than all its neighbors. It's huge because the black hole at its center launched matter so far into space that even the idea of far away starts to feel tired. The Milky Way is about 100,000 light-years across. The radio structure of Alcyoneus is roughly 100 times larger. Next to those plasma wings, our galaxy looks less like a kingdom of stars and more like a footnote. The part that really bothers your intuition is that this galaxy doesn't look anything like a final boss. Scientific studies suggest it doesn't have unusually extreme radio brightness, stellar mass, or central black hole mass. It also lives in a relatively sparse environment, and yet somehow it still grew these invisible wings reaching far out into intergalactic space, as if the universe grabbed a pretty normal galaxy and quietly switched on Greek mythology mode. So Alcyoneus isn't just a giant radio galaxy, it's a reminder that on cosmic scales appearances mean almost nothing. Some things look so quiet, so ordinary, and so harmless that you'd never give them a second thought. And then the full shape finally reveals itself, and suddenly even the word gigantic starts to sound a little too modest. Number 3. Shapley Supercluster, the empire of galaxies. If the universe had a gravitational capital anywhere near our neighborhood, the Shapley Supercluster would raise its hand immediately. It sits about 650 million light-years from Earth in the constellation. Centaurus contains more than 8,000 galaxies, and has a total mass exceeding 10 quadrillion times the mass of the Sun. The European Space Agency has described it as the most massive structure within roughly 1 billion light-years of the Milky Way. In other words, if superclusters were countries, Shapley wouldn't just be an empire. It would be the kind of empire that makes the map sigh and ask for a larger sheet of paper. What makes Shapley so overwhelming isn't just the number of galaxies, it's the density. In many parts of the universe, matter is spread out like someone got a little shaky with the pepper shaker. Shapley does the opposite. It packs galaxy clusters, galaxy groups, and huge reservoirs of hot gas into a region so dense that astronomers have long treated it as one of the greatest concentrations of matter in the local universe. Its core is crowded with clusters that are interacting, colliding, and blasting out intense X-rays. This is not a quiet corner of space built for sightseeing. This is gravity working overtime. Shapley also lies close to the direction in which the local group, including the Milky Way, is moving relative to the cosmic microwave background. For years, studies have pointed to it as one of the major players in that large-scale motion, and ESO has even suggested it could account for roughly half the pull associated with the Great Attractor. It's hard to stay casual about a place hundreds of millions of light-years away that still shows up in the story of where our galaxy is headed. On that scale, far away stops meaning irrelevant. It just means the universe is so vast that even its quietest pulls can reach farther than the human mind was ever designed to follow. Number 2. Laniakea Supercluster, our giant cosmic home. Our cosmic address doesn't stop at Earth, the solar system, or even the Milky Way. It turns out we also live inside something called Laniakea, a supercluster of galaxies spanning about 500 million light-years, containing roughly 100,000 galaxies and weighing in at around 100 quadrillion times the mass of the Sun. The name comes from Hawaiian and means immense heaven, which is a very polite name for a place so huge even a map would probably need a break halfway through. Laniakea was identified in 2014 not because somebody looked up and found a giant glowing sign that said, "You are here." It emerged when astronomers tracked the peculiar motions of galaxies, their movements beyond the universe's general expansion. Those motions form something like rivers of gravity, all flowing toward a massive gravitational low point known as the Great Attractor. Those flows are what define the boundaries of Laniakea. In other words, this isn't just a bunch of galaxies hanging out in the same neighborhood. It's a vast cosmic watershed where tens of thousands of galaxies are drifting in the same direction, like leaves being pulled into a whirlpool so slow it takes billions of years to notice. Our own Milky Way sits near the edge of this supercluster, just one small member of the local group. And the local group itself is only a thin fold in the larger structure. So Laniakea isn't just home in the sense of an address. It's a reminder that what we call home has become so large it almost stops fitting inside the human mind. On that scale, we are not standing outside the universe looking in. We are already inside the current, moving with it, carried by it, and most of the time not even realizing we're being swept along. Number 1. Observable universe, the edge of everything we've ever known. Every galaxy wall, every supercluster, every monster black hole on this list has one very humbling thing in common. They're all just furniture sitting inside a much larger room. That room is the observable universe, the part of the cosmos whose light has had enough time to reach us since the beginning of time. And that room stretches at least 93 billion light-years across. That's the kind of number that makes your brain want to reboot. The universe is about 13.8 billion years old, but because space itself has been expanding the entire time, the farthest things we can observe today are much farther away than 13.8 billion light-years. You are not looking at the edge of the whole universe. You are only looking as far as light has had time to travel to us. Beyond that cosmic horizon, the rest remains outside our view and outside our reach. Inside the observable universe, some estimates suggest there may be as many as 2 trillion galaxies, and each one can hold billions to hundreds of billions of stars. Hubble and Webb have only pushed our view farther back in time, letting us glimpse eras astonishingly close to the beginning. The rest still stretches out ahead like a map that hasn't been finished yet. So the observable universe isn't just the biggest thing on this list. It is the limit of everything humanity has ever seen, measured, and named. And maybe that's the hardest idea to sit with. Every civilization, every war, every song, every question ever asked has happened in one tiny corner of a lit region surrounded by a darkness even larger than that. After all the galaxy walls, giant superclusters, and black holes that swallow light, maybe the strangest thing isn't how big the universe is. Maybe it's that we can still look up at it and try to understand it. One small planet, one ordinary star, one galaxy that isn't special at all, and somehow creatures made of stardust are still sitting here staring into the dark and asking questions. The universe has a way of making everything feel smaller, our cities, our history, even us. But maybe that's exactly why every time we look up, existence feels a little more beautiful, a little stranger, and a whole lot more mysterious. If you enjoyed this journey, make sure to like, subscribe, and hit the bell so you don't miss the next video. And now, take one more look at the night sky, because this time, it probably won't feel the same anymore.